Alright, today's problem. A cannon launches a projectile at 20 meters a second with an angle of 30 degrees from an initial height of 5 meters. And the question is asking us to find the time it takes for it to reach y equals 0. So, let's draw a cannon. Alright, so we have here a cannon with an angle of 30 degrees, firing at 20 meters a second, elevated 5 meters from, and this is going to be the ground. So, we have to break this into two components. So, the vertical component, we're going to call this Vy. This can equal V sine theta. We have a horizontal component, which we're going to call Vx because that's the y-axis, and horizontally is the x-axis, and this is going to be V cos theta. So we're trying to find when this projectile launches and it gets to y equals 0 right here. So Vy equals V sine theta, which is just going to be 20 times sine 30 degrees, and Vx equals V cos theta, which means that is 20 times cos 30. So let's work out these values. So this is going to be 10. This is going to be 17.32. So now that with these values, we have to use this equation. Use this equation that states that the final y value equals the initial y value plus Vy times t minus 1/2 gravity t squared. So let's move it over here. What do we know? We know the final y value, which we're trying to find, is 0. And we know that our initial y is right here, 5 meters, plus Vy value, which we just got, which is 10. 10, and t is the value we don't know, minus 1/2 gravity is 9.8, and t we still don't know. So what we notice is that this is actually a quadratic equation, value that isn't squared and one value that is squared. I'm going to turn this into a quadratic equation form, which is going to be this, which when launched, it's going to create a parabolic curve. So once we converted this into quadratic equation form like this, we can simply either use the quadratic formula to find time, or we can just graph this. Let's graph this. On our calculator, so we're going to graph this. 4.9x squared minus 10x minus 5. Since the calculator doesn't understand t as a variable, we're just going to use x. So we're going to hit enter, and there. It's going to give us a graph like this. When time equals 0, we're going to have to make a new graph and set it at 0 because that's the time. So we have a new graph now, and all you have to do to find the time is hit analyze graph, intersection, and just find the positive x value. And that's going to be 2.46, and that's our answer. Alright, let's test our answer to see if it's true. We have our initial velocity set at 20 meters a second, our launch angle set at 30 degrees, and our initial y value of the cannon is 5 meters. So we are trying to find when this projectile right here hits y equals 0. Let's play it. Alright, let's go back a little bit. So as you can see, at around, y equals 0, because I can't get it exactly to y equals 0, this is y equals negative 0.05, we can see that the time is exactly 2.46 seconds, which means our prediction was just about exactly correct. And yeah, that's our answer. Thank you for watching.